Okay, so we're supposed to find the impedance at omega is 10 to the 5th radians per second. So first of all, it says omega, so you know it's omega. But second of all, even if it didn't, it's in radians per second, so you know that it is. So let's get all of these in the phasor domain. So I will redraw it. Okay, so the 10 ohms is going to stay 10 ohms. We'll do capacitor 1. So I'll call this one capacitor 1, and this one capacitor 2, and this is just going to be our inductor. So ZC1 is going to be minus J over omega C1. And so it'll be minus J over 10 to the 5th times 0.5 times 10 to the negative 6. And just so we don't have to do quite so many calculator keystrokes, 10 to the 5th times 10 to the negative 6 is 10 to the negative 1. So 10 to the negative 1 times 0.5, so that's minus J over 0.05. Now, on your TI-84, if you have not already done this, you'll want to go to Mode, and you'll want to go to where it has Real, and you have your options of A plus BI and RE to the theta I. We're working pretty much today in rectangular coordinates, so A plus BI is good. You can convert back and forth, but this one is good. And also, I want to be in degrees usually, so you want to make sure that you've got that if you're on the 84. Okay, so now I want to do negative J over 0.05. Remember, it's going to be I on your calculators. So on the TI-36X, I is, there's a button that says pi EI. So I'm going to do, I'll do the fraction just because I like to do fractions. And then in the top, negative, and I press that pi button 3 times, and it comes up as I over, what did I say it was, 0.05? And so that's negative 20I, or negative J20, and then you have to go back and forth between I and J. So that's negative J20. And on the 84, it's second in the decimal divided by, oh, it's supposed to be negative, divided by negative 0.05, and we get, again, negative J20. Okay, and then let's do ZC2, and C2 was 1 microfarad, so that is the same except is negative J over 10 to the 5th times 1 times 10 to the negative 6. So that's negative J over 10 to the negative 1, or just negative J times 10 to the 1st. So I don't even need the calculator on this one, so that's just negative J10. Except it's positive J10. Uh-oh. No, I'm looking at the wrong one. Okay. And now let's do the inductor. So the impedance for the inductor is J omega L. So that's J times 10 to the 5th times L was 20, what was L? L is 0.1 milli, so 0.1 times 10 to the negative 3rd. So that's J times 10 to the 5th. 0.1 is 10 to the negative 1, 10 to the negative 3rd. So that's 10 to the 5th So 5 minus 1 is 4, minus 3 is 1, so that is also J10, and these are all ohms. Okay, so now I've found out the impedances for my capacitors and inductors. So I can redraw my circuit. So I'm going to expand this so we can see the original drawing. So it'll be, my resistor stays 10 ohms. My capacitor now is negative J20. This resistor stays 10 ohms. The inductor is J10. This capacitor was minus J10. And we have a resistor that was 10. Okay, now you can use your calculator if you want to add these things that are in series, but you don't need to because it's pretty obvious what they'll be, but I'll show you anyway. So when all you have is a real and an imaginary, then it's just going to be the real plus the imaginary. So like for instance, this 10 ohm minus J20, if I do 10 minus I20, I very surprisingly get 10 minus 20I. And same thing on the 84, 10 minus I20, 10 minus 20I. And so when you add the real and the imaginary, so when we do this, this is no longer a resistor or an inductor. We can just draw it like a little box. So this is 10 minus J20. And this is 10 plus J10. And this is 10 minus J10. So I know y'all can't read that. Now, something interesting is going to happen here. So now we have these two impedances are in parallel. And so we can do product over sum to get those. And so I know what it's going to be without using the calculator, but you may not remember, so we'll practice using the calculator. So it'll be product over sum, so we want to do 10 plus J10 times 10 minus J10 over 10 plus J10 plus 10 minus J10. So on the 84, in case you didn't know, there's a menu that's not obvious that they added at some point. If you press alpha y equals, there's a little fraction menu, and it is very useful to use the fraction on the screen to keep everything straight rather than having to deal with parentheses all over the place. If you have an 84 and that fraction menu doesn't come up, come see me in my office and I'll update your calculator so it has it. So this is 10 plus I10 times 10 minus I10 over 10 plus I10 plus 10 minus I10 and data type. Okay, I probably needed to put the times in there. I did. Still giving me data type. Let me try this. Let me go to its mode. Let me go to maybe this will only let you do it one bit at a time. Like I said, I much prefer the other calculator. So 10 plus I10, it will work on the other calculator, times 10 minus I10 and I get 200. And then if I do the denominator, if you look, the J10s cancel, and I would just get 20, and 200 divided by 20 is just 10. So I don't know why the 84 was having an issue with it. On this calculator, I would use the fraction button, and 10 plus I10 times 10 minus I10 over 10 plus I10 plus 10 minus I10. And it gives me 10 plus 0i, just giving it, saying, yeah, the imaginary part is 0, so it's 10. Okay, so so those two in parallel just became 10. And so I have 10 minus J20 now in series with 10. And so now they're in series, so I can just add them, so my equivalent impedance is just 20 minus J20. Okay, so just for fun, I want to go back and show y'all this calculation right here that we did all of this for. So right here where we did product over sum, it was minus J 15.92 times 50 plus J 62.83 over minus J 15.92 plus 50 plus J 62.83. So on this calculator, I'm going to do, so on the 84, I'll enter it like this: open parentheses, negative I 15.92, close parentheses, no, not close parentheses, times, open parentheses, 50 plus I 62.83, close parentheses, divided by, open parentheses, negative I 15.92 plus 50 plus I 62.83, close parentheses, enter, 2.17. 2.7 minus 18.5. So that was one line on the calculator as opposed to this. And it does the same thing on the other calculator. Okay, so questions on that? Okay, so let me stop this one.